moving ahead, the next important question arises that can the state of matter change? क्या answer है? हाँ. The answer is yes. We can change the state of matter, either solid, liquid, gas, out of all three by just changing two things, that is temperature and pressure. We can change the state of matter, right? So let us see. Before we study the interchange of matter, we need to know about some important definition, that is important terms. uh, 6 या 8 इम्पोर्टेंट टर्म्स है, तो चेंजेस ऑफ स्टेट ऑफ मैटर पढ़ने से पहले हमें ये पता होनी चाहिए, ठीक है? ये सब पहले के स्टैंडर्ड्स में भी हम पढ़ चुके हैं, सो लेट अस रिवाइज इट. Important terms are fusion and melting. Both are same. What is fusion or what is melting? It is conversion of solid state into liquid state, right? How it happens? Upon heating. So ice when heated melts into liquid. What is melting point? Temperature at which solid converts into liquid is called the melting point, right? So if you heat it, it will melt and change into liquid. What is boiling? Boiling is the process of conversion of liquid state into gaseous state upon heating, right? So water when heated boils up and then it changes into gaseous state, that is vapor. Clear? And the temperature at which this process is happening, that temperature is called boiling point. So water at atmospheric pressure turns into gas, that means water vapor at 100 degrees Celsius. So 100 degrees Celsius is nothing but boiling point. Clear? Next is freezing. What is freezing? So it is the opposite of the previous terms we have learned. The process of conversion of liquid state into solid state. But how it happens? When we cool the substance. So water in liquid state, when we cool, when we put it into refrigerator and freezer, it cools and becomes solid, that is ice. And the temperature at which this occurs is called freezing point. Here. Next is sublimation and deposition. Both are opposites. Sublimation in some substances, they don't change from solid to liquid, they directly go from solid to gas. वो solid से सीधा gas state पे चले जाते हैं. तो कपूर जो जिसे हम इंग्लिश में कैम्फर कहते हैं, नेप्थलीन balls that we are using in our home, they turn directly into gas from solid. Even the odonil जिसे हम सुगंध के लिए रखते हैं अपने bathrooms में, तो वो भी डायरेक्ट सब्लिमेट होके गैसियस स्टेट में कन्वर्ट हो जाता है. डिपोजिशन इज द ऑपोजिट, कन्वर्जन ऑफ gaseous state directly into solid. So no liquid state in between, opposite of sublimation, that is deposition. And the last is condensation, process of conversion of gas into liquid, and when it happens upon cooling, right? So water vapor when cooled turns into water. So these were the important terms that were very necessary to understand the future or further topics. Now let us see in figure that what is the effect of change of temperature, right? Because whatever we learned right now, condensation, freezing, melting, evaporating, boiling, they are all related to either you are removing heat, either you are adding heat. So that is by changing temperature. So you see over here the solid particles are there. When it melts, going on to the right hand side, when it melts, the space increases and it turns into liquid. And again when you give heat, it evaporates and changes into gas. Clear? So left to right you see the process, we are adding the heat. Okay. Now the opposite. When in gas, you cool the gas, it condenses to form liquid. And when you cool the liquid, it converts into solid. So left to right you are adding heat, and right to left you are removing heat. That means you are cooling the substance. Clear? So particles obtain heat, their kinetic energy increase, they start vibrating. So due to this their intermolecular space changes and they convert into liquid and gas. But when you remove heat, they change back into liquid and solid respectively. Clear? Now very important part, please pay attention in this part, it is the most important part of this chapter, right? Now the same let us see in form of words. Now here we have solid state, and what did we do? Solid plus heat. So when we heat the solid, what happens? Particle starts vibrating, the intermolecular space increases, and you will think that directly it will convert into liquid. but it is not like that. Okay, solid plus heat, obviously these things will happen, but we still require some extra hidden heat, right, to change the state. To change the state from solid to liquid, we need some extra hidden heat. Then only it will be converted into liquid. Clear? So everything is okay for starting of vibration of particles, for increasing the shape space, we need this heat. But to exactly change solid into liquid, we need this extra hidden heat. And what is that known as? It is known as latent heat of fusion, right? That is the amount of hidden heat energy required to change the state of 1 kilogram solid into liquid at the atmospheric pressure at its melting point. Clear? The most important definition is latent heat of fusion, right? So in short, you have to understand that you heat the solid, obviously there might be some changes, but you need some extra hidden heat. हमें कुछ एक्स्ट्रा हिडन हीट चाहिए तो ही सॉलिड जो है वो एग्जैक्टली लिक्विड फॉर्म में चेंज होगा, और उस एक्स्ट्रा हिडन हीट को बोलते हैं लेटेंट हीट ऑफ फ्यूजन. तो ये इतना क्लियर है? ठीक है, चलो अब लिक्विड को हम हीट करेंगे. नाउ लेट अस हीट द लिक्विड. सो अगेन यू माइट हैव थॉट कि भाई लिक्विड को हीट करेंगे तो क्या होगा, पार्टिकल्स अगेन विल स्टार्ट वाइब्रेटिंग, द स्पेस विल अगेन इंक्रीज एंड नाउ डायरेक्टली लिक्विड विल चेंज इनटू गैस. But no, we still need some extra hidden heat. To change the state from liquid to gas, we need some extra hidden heat, that is called latent heat of vaporization. That is again hidden heat energy required to change the state, right, of 1 kilogram liquid to gas. So then and only then gas state will occur. Okay, so please take care about these extra hidden heat whenever you change the state. Either from solid to liquid it is heat of fusion, and either from liquid to gas it is heat of vaporization. So this is the most important part that I have tried to explain in a very easy manner. Clear? Moving on to the next topic, that is change of temperature, that we have studied. Now let us see what is the effect of change of pressure. So here you see we have a piston cylinder arrangement. यहाँ पे आप देख सकते हो that intermolecular space is highest, so this is gas. Okay. Now if we increase pressure, ये जो piston है अगर नीचे जाएगा तो pressure increase होगा. So what will happen? The space will decrease, right? You see in the figure, and gas, if pressurized, changes into liquid. So what is the effect of change of pressure in gas? If pressure increases, gases turn into liquid. Clear? Now if again we add pressure, what will happen? तो और जो intermolecular space है वो कम हो जाएगा. You see like this. यहाँ पे देख सकते हो. You can see over here uniform arrangement. What happened? Due to increase in pressure, the particles were arranged very perfectly, and what happened? That converts into solid. So gases when pressurized changes into liquid, liquid when pressurized changes into solid. So this is the effect of change of pressure on the states of matter. The last topic of this chapter. बहुत ही easy topic है, that is evaporation. Clear? Now evaporation, one thing you keep in mind that evaporation is different than boiling, but the concept is same. In evaporation you see particles, the liquid is changing into the vapor. Boiling में भी same ही होता है. In boiling also liquid turns into vapor, but the difference is the temperature. In boiling we have to reach to boiling point, then only the state changes. Clear? But in evaporation we don't need enough amount of heat. But the only disadvantage or the difference in boiling from evaporation is that evaporation is only the surface phenomena. If you see carefully in the figure, if you see carefully, we have water over here also, but this lower part, the bottom part will not convert. Only the surface part, the particles which are in the surface, they are having some high amount of kinetic energy. So they are very lucky. Why? Because just by some amount of heat they are able to change themselves into water vapor. Clear? So they are just like, they are volatile materials. The surface particles, they have an advantage that they can, without even boiling, they can change into water vapor. उन्हें boil करने की जरूरत नहीं होती, थोड़ा सा kinetic energy मिलने से ही वो water से water vapor में convert हो जाते हैं, right? So this process in which the surface particles are changed into liquid to vapor is called evaporation. And remember, the temperature is below the boiling point. Clear? So this is the concept of evaporation, right? And we are using that in our daily life. Let us see how. We'll see the factors affecting evaporation. You see, surface area, temperature, wind speed, and humidity. If any of them increases, what happens to evaporation process? If any of one decreases, what happens to evaporation process? Clear? So the first one, surface area. Rate of evaporation increases with increase in surface area. We will take a single example and you will understand everything. Right? Suppose you have a wet cloth. So what do? You increase the surface area, you spread the wet cloth and then it dries early. Okay. So spreading the wet cloth will increase the surface area and it will dry early. So we can say surface area increases, evaporation increases. Moving on to temperature, the rate of evaporation increases with increase in temperature, right? So you compare, the wet cloth will dry early in summer season due to more heat, right? If you compare in any season. So in summer season, as temperature is high, the wet cloth will dry early. So temperature increases, evaporation increases. The next is wind speed. So rate of evaporation increases with increase in wind speed. As you see, if there is more wind, the surface particle will directly or very early change into water vapor and go in the atmosphere. So on a windy day, we can say that clothes dry faster. Clear? Now the fourth one is humidity. Humidity is nothing but it is the moisture present in the air. Okay. Now the only thing which is different, opposite, that the rate of evaporation decreases with increase in humidity. Okay. So if humidity increases, means in surrounding area where we are putting the wet cloth to dry. But if there is in the surrounding only there is presence of moisture, will the wet cloth dry? No, it will not dry easily. Okay, because moisture is present in wet cloth also and moisture is present in outside region also. So there will not be any change in the humidity. There will not be the dryness which we expect. So in rainy season, wet clothes do not dry easily because of humidity. So humidity increases, evaporation decreases. And lastly, one extra, that is nature of liquid. If the liquids are volatile, they will dry faster. Like you see alcohol. If you put on the palm, they will take the heat of your palm and will dry easily. But if you put water droplets on your palm, it will take some time. So volatile liquid dry faster, petroleum, alcohol, they vaporize very fast. But if it is water, it will vaporize at normal temperature. It will take some time. Clear? Now, evaporation causes cooling. This is a very nice topic which always comes in give reason. How does evaporation causes cooling? See, evaporation is an endothermic process. Anything which takes heat, then only it will vaporize. So liquids vaporize. So from wherever that heat is absorbed, that place becomes cool and whatsoever object that it takes heat, it vaporizes. Suppose we talk about the alcohol. If you rub alcohol on your palm, what will happen? It will take the heat from your palm, right? And your palm, if heat is decreased, your palm will feel cool. And what will happen to alcohol? It will vaporize. Clear? So this is how alcohol causes cooling effect because they take the heat from the surface. Right? You see practical example. Ice cold water bottle develop droplets when we put it outside. So what happens? From where does the droplets come from? Do they leak from inside the bottle? No. It is the surrounding hot air that cools and then it condenses on the water. So that is the water from the surrounding. Right? Cotton clothes are used in summer. Why do we use cotton cloth? Because in summer the temperature is high and we sweat a lot. So what will happen? We feel like it is wet. So cotton cloth what they do? They take the sweat from the body, they absorb it, and they evaporate it very fast. So we do not feel like it is wet. We sprinkle water on the roof or ground in summer season in the evening. It is one of our favorite works when we were small, right? We join the pipe from the tap and then we sprinkle the water. Why do we do that? Suppose if in summer your roof is very hot, so inside the room it will also become hot. So what you will do, on the roof you sprinkle the water, the roof is very hot. When you spray the water takes the heat from the roof and it evaporates, right? Now from where does the heat came? From the roof. So roof became very cold. गर्मी जो है वो रूफ से पानी ने ले लिया और पानी वो गर्मी लेके इवोपरेट हो गया, तो अपना जो रूफ है वो ठंडा हो गया, ठीक है. And acetone alcohol rubbed on palm, you see deodorant we put on the palm and it evaporates very quickly, so that is due to evaporation, right? So liquids, they take the heat and they evaporate, and from where the heat is taken, that surface becomes cool. Clear? Now extra important stuff you have to know from this chapter. We are ending the video. Converting degree Celsius into Kelvin. Now Kelvin is a standard unit of temperature. So we are using Kelvin in chemistry. So if you want to convert Celsius into Kelvin, you have to add 273. For example, 100 degrees Celsius, you add 273, it becomes 373 Kelvin. Clear? Now the opposite. Converting Kelvin into Celsius, you have to subtract 273. For example, 300 Kelvin. So you subtract 273, it will give 27, but that will be 27 degree Celsius. Clear? And the next important part is the difference between boiling and evaporation. See, boiling occurs at fixed temperature, which is known as boiling point. But evaporation occurs at any temperature which is below the boiling point. So we don't have an evaporation point. It is random. Okay? Boiling, when we boil something, it boils whole. Suppose you put a water in a container, and when you boil it, the particle at the bottom is also at the same temperature as well as the particle at the top. So it is a bulk phenomenon. It happens in whole container, but evaporation only takes place at surface. Okay? When you boil, you give extra amount of heat, so heating takes place. But in boiling it is not there, you correct it, here it is the evaporation. Cooling takes place during evaporation as compared to boiling. Now, boiling is a fast process, evaporation is relatively slow. Heat supplied by external source in boiling, and heat is supplied by surrounding, right? So evaporation of water, that is taking place very slowly all the time, 24 hours from the surface of ocean and seas. Clear? So this was all related to chapter 1, that is matter in our surrounding. Hope you cleared all your concept that is in the chapter. If in case you have time, you study all the activities, right? And then again you rewatch the video if you have any kind of doubt, and again if you have doubt, you mention that in the comment section. I have used little bit Hindi so that everyone can understand. So that's it for today. Thank you.